Hello, my name is Lindsay Goulet and I am part of Metagenomic unit at INRAE France. Today I'm going to talk about Crocodile, a deep learning tool for the detection of well-to-well contamination in metagenomic data. We know that the intestinal microbiota plays an important role in health and that is linked to various chronic diseases. An increasing number of projects, such as the French gut, aim to study this microbiota. In this context, the detection of well-to-well contamination is crucial but time-consuming. Well-to-well contamination refers to the contamination of one sample by another, processed on the same plate during wet lab steps. This type of contamination is highly recurrent, but it remains understudied. If not detected, it can lead to biased results and eventually to false conclusions. Here we introduce Crocodile, a tool for detecting this contamination. Crocodile works with related samples like mother and child and allows the discrimination of contamination sources from contaminated sample. It can also estimate contamination rates and does not require costly negative control. Within Metagenopolis, the procedure used to detect contamination consists of observing abundance profiles of a pair of samples. There are three key points to understand how this procedure works. The first point is that above a certain threshold, all the abundant species of the contamination source sample are present in the contaminated sample. The next point is that a subset of these shared species have a proportional abundance between the two samples and form what we call a contamination line in yellow here. This line corresponds to species that were not present before the contamination event, in purple here. The last point is that this contamination line is used to detect contamination events, and the contamination rate can be estimated from the value of the intercept. This procedure is extremely time-consuming, which is why we restrict ourselves only to highly correlated sample pairs. But correlation is not suitable for whole cohort, especially those with different microbiota or longitudinal samples. Crocodile is a deep learning model. It takes as input a matrix of pairwise abundance and outputs the class prediction, either contaminated or non-contaminated. For the training step, a semi-simulated contaminated dataset using real data and varying the contamination rate and sequencing depth was generated. For the non-contaminated dataset, one part used real data with different sequencing depth, and the other part used sample pairs from different cohorts. Performance was evaluated on 3 real datasets. First, we can confirm that the correlation method doesn't work for the low and highly correlated sample. Next, we can clearly see that Crocodile outperforms this method in terms of sensitivity for the 3 datasets. However, it still produces many false positives without a contamination line. This suggests that the model uses its own criteria beyond the ones used by humans. This is why, at this time, we recommend Crocodile as an aid for human inspection, rather than a fully autonomous approach. We intend to improve the training dataset to increase model performance. Next efforts will extend the use of this modeling approach in the way of identifying contamination levels and working towards the automatic decontamination of samples. Thank you all for listening to me, and if you have any questions, feel free to email me. Thank you.